Hey there. We throw around the words smoke and smog almost like they mean the same thing, especially when we look up at a hazy sky. But what if I told you they aren't the same at all? They are actually fundamentally different pollutants with totally different causes and, yeah, different dangers. So today we're going to clear the air, literally, and break down what's really going on up there.
Right? You know that feeling. You look out over a city and everything just has this fuzzy brownish or grayish filter on it. It's not quite crisp. And you're left wondering, is that just fog? Is it something worse? Well, that haze, more often than not, boils down to two main culprits: smoke and smog. Let's tackle the first one.
So first up is smoke. You can think of it as the OG of air pollutants, the one our ancestors were all too familiar with. It's probably the most basic and visible kind of air pollution. But don't let that fool you. Its story is way more complex than you might think.
So what exactly is smoke, in a technical sense? Well, it's a pretty wild cocktail of stuff. We're talking tiny airborne solid bits, like soot, little liquid droplets, and a bunch of different gases. And it's all the result of combustion, which is just a fancy word for burning something. And where does all this smoke come from? Well, the sources are pretty much everywhere you look. You've got the big obvious ones like giant industrial smokestacks and the exhaust from all our cars. But then you also have massive natural sources like forest fires, which, as we all know, are getting more and more intense. And hey, even smaller scale stuff like burning waste contributes to the overall mix.
The effects of all this smoke are, well, they're seriously far-reaching. It's not just about a scratchy throat or watery eyes for a day. Those tiny little particles can get lodged deep inside our lungs, triggering or worsening serious problems like asthma. And it goes beyond our own health. Smoke absolutely crushes visibility, and those particles can travel for hundreds of miles, eventually settling on our lakes and rivers, blocking sunlight that aquatic plants need to survive.
Okay, so that's smoke by itself. But here's where things get really interesting. Smoke rarely just stays as smoke. When it gets out into the atmosphere and starts mixing with other things, especially fog and sunlight, it can morph into something way more complex and frankly a lot more dangerous. It becomes smog.
The word itself is actually a huge clue. Smog is what you call a portmanteau. It's literally a mashup of the words smoke and fog. The term was invented way back in the early 1900s to describe that thick, choking, soupy air that hung over industrial cities. But, as we're about to find out, not all smog is created equal.
And this right here is the real heart of our explainer. You can think of smog as having two totally different personalities, two distinct faces. One is that old-school industrial smog you'd find in a place like London a century ago. The other is the modern sun-powered smog you see in a city like Los Angeles today. This chart really nails the key differences. Okay, so on the one hand, you've got London smog. It thrives in cold, damp, humid weather. Its main fuel source, coal burning. And it has that classic, gloomy, grayish look to it. Then, on the other hand, we have LA smog. This one needs warm, sunny weather to even exist. It's caused primarily by vehicle emissions, and it creates that infamous brownish haze you see hanging over the city. Let's start with the classic villain in this story, London-type smog. This is the smog of the Industrial Revolution. It's powered by coal and defined by its nasty mix of sulfur dioxide and all those tiny particles. And if you want to understand just how bad this stuff can be, you only have to look at one date, 1952. In London, a freak weather event trapped coal pollution over the city for 5 straight days. The result was the Great Smog, a disaster that was a massive, tragic wake-up call for the entire world and ultimately led to the first modern clean air laws. Okay, now let's fast forward a bit and jump across the ocean. In places that are sunny and full of cars, a totally new kind of smog started showing up. This isn't your grandfather's smog. This is a completely different chemical beast. So, how is this modern smog made? Honestly, the best way to think about it is like a recipe. First, you take your primary ingredients, which come right out of your car's tailpipe, things like nitrogen oxides and volatile organic compounds, or VOCs. Then, you add a really important catalyst, intense sunlight. The sun basically cooks these pollutants, sparking a chemical reaction that creates a whole new batch of nasty secondary pollutants, with ground-level ozone being the worst of the bunch. Let's zero in on those chemical culprits for a second. With the old-school London smog, the big problems were sulfur dioxide and particulate matter, coming almost entirely from burning coal. But for LA smog, the main problem is ground-level ozone. And here's the crazy part. Ozone isn't directly pumped into the air. It's created by those chemical reactions in the sunlight. This modern smog also includes a whole cocktail of other irritants that give it that signature sting in your eyes and throat.
And make no mistake, the health effects of this photochemical smog are really, really bad. It's famous for that burning, watery sensation in your eyes, but the damage goes so much deeper. It can seriously aggravate respiratory conditions like asthma and is even linked to long-term heart and lung problems. And it doesn't just hurt us, it's incredibly toxic to plants and can wipe out entire crops.
So, we've met our main characters, Smoke, and its two very different kids, London Smog and LA Smog. Now let's pull back for the big question. Why does really getting this distinction matter so much? Why go into all this detail?
Well, because this isn't just an inconvenience. It's not just about a city skyline looking a little ugly. As the research makes crystal clear, air pollution is a massive environmental problem. It affects everything. Ecosystems on land, in the water, sometimes hundreds of miles away from where the pollution even started.
So here's the most crucial takeaway. We can't fight air pollution with a one-size-fits-all solution. It just doesn't work. The way you tackle the sulfur-heavy, coal-fired smog of a cold industrial region is completely different from how you fight the sun-baked, traffic-jam smog of a modern city. Understanding the chemistry of the haze above you is always the first step to truly clearing the air.
And that brings us to one final, kind of unsettling thought. We can often see thick smoke. We can see that brownish haze. But many of the most dangerous pollutants we've just talked about, like ground-level ozone, are completely invisible. Which really makes you wonder, doesn't it? On a day when the sky looks perfectly blue and clear, is the air you're breathing actually clean?